Let's get started. Welcome, everybody, to the last session. You're still all here. Wow, that's some dedication. I want to always get to know the audience a little bit before I start. So just a couple of things. Who here has ever written any sort of code that talked to an LLM, to a large language model? Some people, yeah? Who did that in C#? Right? Who did that in Python? 2 people, 3 people? Okay, good. Who was here for the last session in this room from Hakon? Couple people. Okay, good. That gives me a little bit of like an idea of where we're going with this, which is exactly what I prepared. I'm not changing anything. What we're going to do, we're going to talk about code-first LLMOps. My name is Matthijs. I work for a company called Zebia. I'm a coding architect there. It just means I like just writing software, but also designing software. I don't think you should do either. You should be doing both. I'm a consultant, which means I talk a lot, and I prefer to do that on a stage, so I'm making this your problem today. If you would have told me a year ago that I would be talking about LLMOps, I would have said, nah, that's never going to happen, because while I'm a huge proponent of DevOps, any other ops has never really caught my eye. I always thought, well, why do we need to talk about that? Why is there a SecOps, and a DevSecOps, and a GreenOps, and a FinOps, and any more opses out there? I heard BizOps. I don't even know what that is. It's just operating a business, I think. So LLMOps was weird for me because I was last year sitting at a conference, much like you. I sat on the first row, very daring. And the title of that session definitely was not anything to do with LLMOps. But in the first 5 minutes, the speaker says those words. And I think, oh, I can't leave. I'm on the first row. I can't even sigh. I can't even breathe too loudly. They will know. But 2 things happened. In half an hour of that presentation, I became a convert. I believe that this is something we should be talking about, at least for the upcoming few years. And a second thing was, every LLM-based application I had built, I feel like I've done in a very bad way. Luckily, that was no client work, but I'm going to show you what I used to do, and then we're going to gradually improve on that to show you what I mean when I say code-first LLMOps. We're going to use 2 tools for that, Semantic Kernel and Prompty. I will introduce them as problems arise that they can solve. The most important thing is, I think when we are building GenAI applications, we deserve better tooling. A lot of this is still in preview, but at least I think that this is the tooling we should be using to deploy and monitor and build GenAI applications with confidence. That should be really what this talk is about. So, LLMOps. If you Google that, there's a ton of people saying different things. So I'm just going to set the record straight of what I think LLMOps or LLMOps should be. And that for me is taking a proof of concept or building that proof of concept, selecting the proper model, yes, that goes after, we'll talk about that, and then going into that development, testing, deployment, and monitoring that we know and love and can repeat. That is, for me, LLMOps. We're not talking about building LLMs. We're talking about using generative AI in our systems. In this presentation, I'll be going through these blocks, which means we are going to skip testing. I'm sorry, but that is a 45-minute presentation on its own. We'll talk about it briefly, maybe. You can find me after this session and just talk my ear off about testing. We will touch on deployment a little bit, but these orange blocks are really what we're going to focus on, starting with the proof of concept. Imagine, for a moment, your product owner or whoever decides what we should be building calls you. And they call you and they say, hey, Matt, I have this great idea for the next product. It's all AI. We'll have like a classic recipe, like a well-known recipe, and we'll add a twist to it. And then we'll build an application that will generate a new recipe. There will be some collaboration mode, super shiny, AI, everything. And then I saw Star Trek. We just fabricate the food. Great, you built that. Doot, 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 and a phone call. You now have 2 jobs. 1, update your resume because you need a new job. But 2, let's go and try to figure out the manageable parts of this proof of concept, because there is a lot of stuff that we can do. So I'm going to show you what I've built, and then we'll talk about how you could build something similar. If you think, hey, I know this layout from the previous presentation, that's because I told Hakon, please use the same setup. I just didn't think he would copy the whole presentation. So if it looks familiar, that's why. This application, though, is much more fun because it allows you to choose a well-known recipe, add a twist. Can be all kinds of things, although if you do choose famous landmark, it always goes for Eiffel Tower. It's just very biased. It will create a recipe, instructions, then a very well-known critic will go and criticize that recipe. in this case, with some good feedback, get back in the kitchen and make it come to life. That goes on and on and on until eventually, this is as close that I got to fabricating the food without actually having to go into 3D printing. But that's sort of the application that I'm envisioning to build. I'm going to show you basically how I would start doing that. So the way I usually did that, let me get the demo up, is as follows. So used to be, if I needed to do anything with an LLM, the first thing I would go is just build basic code using the Azure OpenAI SDK and figuring out, let's just make a call. Let's not make the call, just any call to the LLM to make it work. So I'm going to do that. Is this, do I need to zoom in for the people in the back? No, I also can't hear you because I'm the one with the microphone, so this is fine. I saw them shaking their head, it's fine. So just get the basic code in to make any call to an LLM. There, so we make a client. We need that to talk to Azure OpenAI. We have an endpoint. We use the default Azure credential, which means it's using my credentials here and my services credential in the cloud. And we're just going to use GPT-4o Mini because it's very capable. But we need sort of the basic minimal code to make a call, which is a system message. For those of you who don't know, that's just sort of the basic message that is sent with every message to the LLM. And we're not going to do the actual use case yet. We're just going to make sure a call, any call, will be happy. We'll have a chat history. Otherwise, we can't have a chat with this model. And then we actually send the message. Send the message and get the response. So this is how you send the message using the Azure OpenAI SDK. Why I don't like this? Because if you then want to just print out the text, it's a very, very normal thing to say. You just get the result of value, the content, but the first one, and then .text. Intuitive. This SDK is great. This, I don't like. But I did this every single time I was making just a proof of concept to talk to this API. So I'm going to just .NET run this. Gesundheit. See if it works. This should ask, we can just say where we are, and then it will make some food for us. But we're in Utrecht, and we don't have any good food. Any city, just a city with better food. Well, just for the fun of it, we'll do it. But I don't think it's going to be much better. So this will hopefully do a call to GPT-4o Mini, and we'll get a response. If this works, we're good to iterate on this. Apparently, David to cook, that's a thing? Yeah? Okay, well, cool. It made sense. It didn't completely hallucinate, but our cuisine isn't that rich. But apparently, Deventer Cook is the place to be. Okay, we made a call to an LLM. This is great. This is the basis for our proof of concept. We're going to do more stuff because from here on out, we're basically just doing prompt engineering. We're going to iterate on making this a better prompt so that we get a better result. Eventually, that result with the recipes and the twist and everything. So first thing we need to do is we're going to add, right here, some options, some parameters. These things are important. Yeah, feedback is also important. These things are important when you start talking to an LLM. The max output token count is meeting, don't make the message too long, thank you. Temperature is very important for anything prompt engineering. Like, anybody knows what temperature means in the context of a large language model? No? No? Cool, because then I can give the longer explanation. So a large language model, if you don't know, it takes text input, but it doesn't know what text is. What it does is it chunks that up in little bits we call tokens. Tokens are just numbers. Computers do know numbers. It looks at that entire set of numbers, and its only job is to guess the next number. But it doesn't just guess one number, it guesses a set of numbers. The top one being the most likely number there is, and then less likely numbers. What that means is if you have a temperature of 0, it is very likely, most likely, to pick the most likely text. It becomes very robotic, becomes very predictable, but still non-deterministic, but very predictable. If you set the temperature to 1, it becomes very random. Your demo will fail. It's very fun. It will be more likely to choose less likely text. I like to think of it as if you want more creative writing, up the temperature a little bit. Like, do you want to be an LLM? Do you have any ambition to be an LLM? Let's say yes. Okay. I know you're shaking no, we're going to do it anyway. Let's say the temperature I set on you is 0. So you're going to just say the most likely thing there is to say. And I say, we are such good friends, we always finish each other's Boom, a little round of applause for the willing LLM. So that is temperature 0. If I had set the temperature to 1, it might have been, we're such good friends, we even finish each other's peanut butter. Could have been anything. So that's why that's super important. There are way more settings that we can influence to make our prompts run differently. But the most important thing really is the prompt itself. So I'm going to do, because this system message is not long enough. We need way more instructions, guardrails, so it'll probably become a little bit more like this. It's probably going to triple in size while we start iterating. What I don't like about this is what I did every single time. And again, I now think this is wrong. Because what I see everybody do is then say, okay, this is a bit long, so maybe we make this something else. We say var, and we put this in a different file, and we get file.read here, just to get it out of the way. And then we take this, and we might put this in our dependency injection somewhere. We take this client, that is definitely going into dependency injection, but now our model is sort of tied to the entire application. I think this is terrible, yet I see everybody doing this. This is just, the SDK doesn't allow you to do anything good, anything of quality. There is a solution to that, luckily, but it has to do with what is prompt engineering. And we're not going to do a deep dive, but prompt engineering, I think, has sort of 3 parts to it, 3 very important parts. The first one being the prompt. Yes, you guessed it. The stuff, the text that goes into it will determine the output. But I also already talked about temperature, or you talked about temperature, I guess. We talked about temperature, and the parameters are a very big part of prompt engineering. This is something you will often change as you are doing this engineering. There's a third part very important to prompt engineering. Anybody? The model, yes, 100%. And it is one of the most overlooked things during prompt engineering, together with parameters. So if you look at documentation on prompt engineering, everybody's like, yeah, use these strategies and write your question this way. The model has so much input on how this is going to react. These 3 things, that's prompt engineering. So splitting them up across multiple files means things in your application start changing together for one change. These should really stick together, right? Basic cohesion, things that change together, stay together. The solution for that is Prompty. So some of you have seen this in the previous presentation. I'm going to pretend it's new for you as well. Because Prompty is a very, very, very good and useful tool to do exactly this part, this prompt engineering, this proof of concept. It is very simply an extension. I'm going to show you a few things that it can do. If you have this extension, you'll notice, by the way, that I'm not just using a preview. I'm using the preview of a pre-release. This is so, it is stable to, well, I'm daring to do this without a recording, but that's about my comfort level. I do run this stuff in production, though, because it is very fun. But every morning I wonder, will my demo work? Prompty, however, when you install this as an extension, this is the future of prompt engineering, really, for anything code first. You can just go into any folder and say right-click, and then find new Prompty. It just creates this file for you. Super useful file. Now, you're going to read this, so I might as well switch to the real file. The Prompty file, it basically is Markdown, but none of this in the first screen here is Markdown. It's all front matter, it's YAML. But this is a lot of, let's say, metadata for your prompt. The first here, already super useful. Because I give this presentation every once in a while, eventually it'll be a while before I come back to this, but then I can still see, the name of the prompt is the thing. There's a description. I remember now that I wrote this. But then we immediately go into a lot more important stuff. So what are we doing? We're making a chat API. So we're sending chat history and getting stuff back. We're using Azure OpenAI. We're using a certain model, one of the most important things of prompt engineering, right there at the top. We're setting those settings right here. We can do blue. There, that's blue. To set the settings, meaning that the model, the settings are now at the top of the file. We haven't even gotten to the prompt. The really cool stuff is these inputs. You don't need them, but they make any other piece of application that works with Prompty better. So just fill them out anyway. But the most important part for me is this, the sample data. This is really annoying, isn't it? Can we fix the whistling? Because I'm sure I'm not whistling, but something is. I'll continue though. This sample data. Because if you have a prompt and if you ever did this in C#, you probably had like a little curly brace template somewhere and it has a name of a variable, but it doesn't explain what should go in there. But looking at this Prompty file, you can say, oh, this is just basically a title. And there's a description that is multi-line, and there's a twist that is just one line. This tells the human reading this, like, oh, this is what we're doing. And only then do we actually go into the prompt engineering prompt part. So saying, here's the system message with some context and templating. No more string replacing anything. This is great. And this templating language is called Jinja. You might use it for in some other context. That also means that you can do for loops through your input. Your input could be a collection of items. You could also do if statements. So if the original dish is there, print out this piece of text. If not, do this other thing. That makes it a really powerful prompting tool. And the coolest thing, if you have this, we add a user message, and we just do F5. Boom. See if it works. And just by hitting F5, I now have the result from a large language model. Wrote zero code, just had an extension, hit F5, works. And I can keep editing this file, keep committing it to my Git repository, and have just a perfectly good Git history of my prompt engineering journey. This is super powerful. One of the best reasons to use Prompty. An even better one is I like it because this one always fails. Because for the people who are looking really closely, we don't want that. We ask for JSON. Yet the LLM is giving us backticks before the JSON. That's because I didn't offer a lot of examples. But Prompty allows you to do that, make that change really quickly as well, just by saying, actually, make the response format a JSON object. I'm going to hit F5 again and hope it works. 1, 2, 3. There we are. And now it's forcing it to be JSON. This is a capability on the newer GPT models. That's also a good thing to mention. By default, Prompty supports all the GPT models and therefore also the Ollama interface that is ChatGPT compatible, but there are some more things that you can do with it. If you have access to a GitHub account, which all of you do because it's free, you could also go here into GitHub Models. GitHub Models is just, you get a little bit of token quota for free to start your development journey with LLMs. And now I can go to this Prompty and say, what would that look like on a 70 billion parameter llama? Which are weird words to combine, I guess. But we can see how Llama does with this prompt. So we can already a little bit start thinking about model selection, but we're not really doing that yet. Showing that, so here, if you do this, I love this, because if you do the same prompt to that Llama model, it actually becomes very chatty. It will give me eventually JSON, but first it's going to talk about it a lot. So I know I would have to change my prompt. Again, models really matter for prompt engineering. One more thing I want to show. There's this test page, the test chat page here on top. This is a talk about code first, but if you have somebody who's less technical in your team, maybe your product owner wants to play around with this, there is a test chat page that you can give them. So you just run this. Prompt flow will start with this. We'll talk a little bit about that later. Come on, give me some test chat. So here we could just have a chat. So we could say, we will use the chat input will be the twist. So we can say, made completely out of bricks. Oh, that was a good twist. We're not going to wait for the response. What is cool about this is that you can have a human do this, add some stuff. They will add stuff that you never thought about, and you can see all the traces come in. We're going to talk a lot more about those later, and also see how many tokens were burned, that kind of stuff. Already get early on some sort of sense about how much is this thing going to cost without actually having to do the calculation. You just run this. So that's Prompty. It will come back very shortly. It's also got the cutest mascot. So model selection. Why I said model selection after the proof of concept is because model selection you could do for weeks if you wanted to, because it comes with a bunch of fun graphs. This is Azure AI Foundry with how accurate a model is. How accurate a model is based on a ton of different benchmarks that Microsoft ran against it. You don't have to read the labels. It just better models to the right, worse models to the left. There are so many tests, so many metrics that model anything, like model selection, is just a tough job. But what people keep saying, and they do work for Microsoft, so I guess that makes sense, is just start with OpenAI. Just get a sort of capable model. Like 3.5 Turbo is fine. I just used 4.0 Mini. It's fast, it's cheap. Why not start there? Once you show, yes, my idea has merit, it works, ask somebody to look at this. And then most importantly, in the last 2 months, they finally added a feature that is actually the most important. This is accuracy versus cost. So that there is 0.1. It's very accurate. It's also hella expensive. So look at the cost as well if you're doing model selection. Don't just go for the best thing, also go for something that is actually economical. And again, I will say this for probably another 3 years. 3.5 Turbo is really good. Just keep using that. Like even for creative writing, it does very well. So model selection after your proof of concept, before you go into building anything important. Then if we start talking about building actual features with it, adding AI to your application, whether it's an existing one or a new one, that we do through something called orchestration. So because we have done nothing so far to actually use that Prompty file, right? We have a Prompty file, it seems to work. How do you put this in your code? Get the next demo running. There we go. So what we have, when we have a Prompty file, you could Google how to do this, but you can also just go and right-click on your Prompty file and say, add code. I'm going to zoom in. So you can just choose, let me use the Prompty runtime, which is Python, prompt flow, Python, LangChain Python, and then finally, my favorite, because it's C#, Semantic Kernel. So if you wanted to do this in Python, if you wanted to run a Prompty file through Python, you could just say, give me some LangChain code. And I do this a lot because I like using Python, but I'm not good at it, so I just like generate and then have Copilot figure out the rest. But this is how you can learn how to use Python or use Prompty. I'm, of course, going to use hello, the right file, and then say semantic kernel. And this is what the Prompty developers think you should be doing with a Prompty file, except that bleep bloop. I think that's in my environment setting somewhere. I have not been able to get that out. This is pretty good. If you know semantic kernel, you'll see a few things. So the semantic kernel is built around the kernel. So first you make the kernel will have plugins, the plugin will have functions, and really what we're doing here is we're saying, please add a function or make a function from our Prompty file and then invoke it. That's the only thing we need to do. But I don't like all of this. I think it's bad sample code. I think we can do better because I do not want an API key here because you'll take one picture and be done with it. I'll be out of tokens in no time. So yeah, right? So I saw the phone. So we can do better, and we're going to do better. So what we're going to do, I have here the solution file, to the website that I just showed. So that website has 2 pages, but it's got 6 projects because I love over-engineering, and now I'm going to make it your problem. But it does mean that I split things up where I put my AI stuff and my observability stuff and my web stuff. So what I'm going to show you is in the AI part, how I set up that semantic kernel with all the Prompty things. So we're going to start here. Give you all a little bit more space. There. First thing I do is I don't add 1 model, I add 4. So the first thing here that's happening, I say we are going to bootstrap just all the models that I care about. So I use 3.5 Turbo, 4.0, 4.0 Mini, and DALL-E 3. Why? Because per prompt, and I've got, I think, about 5 now, I can choose a different model. So if I have a very simple and fast thing I need to do, 3.5 Turbo. If I have something more creative, 4.0 Mini. Or if I want to spend more money, 4.0. I have those options now, and I could just add multiple because you only pay for what you use anyway. So just add more if you have them. This is a really simple setup. This is basic semantic kernel, nothing to do with Prompty. We do go into adding Prompty functions here. This is a function I built myself because I don't want those Prompty files to be read every single time somebody presses that button. That's one time at the start and then be done with it. So what I do is I check, I will create a plugin. Plugin, just think group of functions. That's the only thing that you need to know about a plugin. And every prompt that I have, which I've saved here, will just become a function for semantic kernel to execute. So what I do is I scan where am I, basically, where am I running this, then scan the directory of prompts, and then for each prompt I add it, and there's one line of code, which is this, kernel function prompty dot from prompty, put the text in, and then be done with it. When you do this, your editor will start screaming at you with like big red not warnings, errors saying, do not use this in production. Whatever you do, do not use this in production. But you can ignore those errors and just continue your work and definitely use this in production. I use this in at least 2 client applications. It's fine, it's stable. If any time Prompty has a breaking change in the future, it's very easy to just make it a regular semantic kernel function. And you will have had all of the useful things of making your Prompty file. But at this part, none of the Prompty runtime is in your app. It is just text being put into a template. There's no it's being recorded. There's no security risk. I'll just say that with as much confidence as I can muster. But this part, it will scream at you for saying, like, it's not ready, it's experimental. I've disabled that so that it just works. This allows me to go into any part of my code. So there is a part of my code that creates the recipe, for instance. So if I create a recipe, that's done by the recipe service, and right now it's just some hard-coded recipe that's coming out. But instead, I'm just going to add code to call the LLM instead. So what I do, here I inject the kernel. That's all I need. And I will take this beautifully prepared code. Plop. We will remove this delay because now we're going to use actual AI. There. So what did I just put in? What we need to do when we call a semantic kernel function, we want to supply it with arguments. These are actually the same arguments that we had in our Prompty file, right? So the dish name, the dish description, and that twist. They are kernel arguments, and we will put them in promptly. So I didn't mean to make that joke. Then what we say to the kernel is, let's invoke a function. And I know this function by name. Semantic kernel can do a bunch of smart things, like plan your own function execution. We don't want to do that. We're keeping this simple. We know that in the plugin named Prompty, we have a function that's called create recipe. We give it some arguments. It goes and runs, and then eventually we'll have some results. So I'm just going to put a breakpoint here so we can see if this works. But this is all the code for any time I want to interact with any LLM that I have to write. Get a function, execute, do something with the result. And this result is JSON, so I'm just deserializing it to a class or a record that I have and use it that way. Here we go. There we go. So, Pad Thai, want to see if we get another Eiffel Tower. We will hit that breakpoint very soon, because 4.0 mini is just very fast. Come on, he said. Ah, there we are. And now we can actually see what happened with that. So at this point, semantic kernel doesn't even know about Prompty anymore. It's just, I have this function. If I execute it, something will happen. And we can see here what function was run. It's very small. I'm just looking for an interesting part. We can see the prompt that was rendered by that template. So this will eventually say, here's the Pad Thai. This is the rendered prompt that actually goes to the model. We have a better way of showing this soon, but this has all of the details of what that function has done, even what model was called, but we don't care. We got text back. So if we get text back, we can make a recipe, and then we can fabricate it. It's pyramids. That's great. No longer Eiffel Tower. But that is the 5 lines of code that you need to do to call any LLM from this point on by doing that bootstrapping once. And the files, the Prompty files, they were read once. They're not being read every single time. They're just done. And that's important. Then, that's beautiful. I spent way more time on this part than the other parts, and we're not even talking about this. There we go. So I did mention a bunch of different things just now, right? I'm using semantic kernel because I like C#. It's where my skill set lies, and it is sort of being seen by people as the enterprise-ready, orchestrator, LLM abstraction layer. But that's also because every time somebody says Microsoft, everybody who doesn't use C# goes, "Oh, Microsoft is corporate. It must be very enterprise-ready." It's just a very capable orchestration framework. It does all kinds of clever things like planning, using plugins to actually interact with the real world. You've seen probably 3 presentations of people turning on and off lights in a console app. Just today, I've seen at least 2. It can do all of those things. But it's also a very capable orchestrator just to run a function. It abstracts away what API we're talking to. So if you're using Python, you're probably doing this with LangChain. You're probably now thinking, I don't want to use LangChain, I want to use LangGraph, but LangChain is still sort of the de facto standard for talking to LLMs if you're a Python developer. PromptFlow, however, has a very special place because Microsoft sort of puts this in the dev to production lifecycle, and I think it should only be here. Development and testing with PromptFlow is pretty interesting, especially the testing and seeing how what is the quality of my prompts while I start iterating. Don't use it in production. Again, this is recorded, so somebody will tell me to stop this, but I wouldn't use that in production right now. But PromptFlow for development and testing is really great. It's also what powered that chat page that I showed you. It's a very capable orchestrator. There will be a ton more coming out soon, but I think Semantic Kernel is in a really good place to just be the standard for anything .NET. So deploying, then. Let's talk about that very briefly, because you might think, ooh, deploying an LLM, that must be difficult or at least very expensive. It takes $40 million to train a new version of 4.0. How do I deploy one? Just this is it. This is Bicep. If you use Terraform, works. If you use ARM, I don't know why, but if you like Pain, that's possible. This is a little bit cleaner, maybe. If you have an Azure OpenAI instance, this is what it takes to deploy a new model. Because really, you're not deploying a model. You're just getting access to the shared infrastructure where that model was already running. So for any of the pay-as-you-go GPT models, this is it. So I add, you can parameterize this and just say, give me this list of models. So I have 3.5 Turbo, 4.0, 4.0 Mini just deployed because if I'm not using them, I'm not paying for them anyway. This actually really saved me, and we're going to talk about that later when we talk about monitoring, because this makes it really easy to also switch between different models. But this is it. Deployment, infrastructure as code, just the same way we hopefully always do it. When we go into, after deploying this, right, this is the only special thing for an LLM. The rest is just deploying an app to Azure, in this case, using a Blazor app on an app service. You're going to get a lot of questions. People will want to know if the app is running. That is something we've all sort of figured out already. So getting basic telemetry going for your application, seeing how many requests are coming in, what the metrics are. But what is interesting for an LLM is that this is usually followed by this question. What does it cost? Because I've been saying, oh, look how great, you only pay for the tokens that you use. But what is a token, right? How much tokens are in a message? What are users putting in their message? How much is the model responding with? You could do, if you use that chat page that I showed before, you can see how many tokens were used, and you could maybe then make a calculation. Well, we have maybe 5,000 users sending one message each, so times this, times that. It's an indication of what it will cost. I think the best way to check what an application costs is to run it and monitor it very well. That doesn't mean monitor it for a month and then the Azure bill comes in. The Azure bill always comes in, but that's a little bit too late to start explaining to the business that it's going to be expensive. You want to maybe do that on 1, 2, 3 days and know what happens there. So we're going to talk a little bit about observability, specifically for using Semantic Kernel, using Prompty, using code-first LLMOps, and not all the stuff we already know. So, I have a note here to remove the breakpoint. I always forget, but it's gone. So just like all the AI stuff, I've put all of the observability things in one basket. There, put that square right over it. I use OpenTelemetry because I like OpenTelemetry. It's a very mature framework that a lot of people are using right now. It plays well with a lot of different services, including application insights. A very basic OpenTelemetry setup will look a little bit like this. This whistling is not going to go away in the next 10 minutes, I can tell. So what I'm doing is I'm just making sure that I have metrics and traces enabled. So metrics being how much of a thing has happened, and tracing being where did the thing happen. And by default, I also have logging enabled, which is the why did it happen. If you have all three, and if you say specifically add semantic kernel anything, that means the Prompty extension, the Azure OpenAI extension, everything here will just be now metered and traced. That's exactly what we want. So running this, I'm going to restart it. I run this application, which was already over-engineered in Aspire to further over-engineer it, but that comes with a really good benefit. It will automatically start up the Aspire dashboard, which is here. And the Aspire dashboard, yeah, believe me, it's annoying for me too. Like hearing myself is already here, but then the whistling makes it extra. It's hearing myself over twist, that's true. Appreciate that. So we now have this dashboard going, which means that anything that happens to my application, I can now see. So if I go into traces, I will see just connecting to this website has already done something. I'm going to make sure I just refresh this page to make the trace happen quite nice. We have 8 minutes, so who wants to, any of these? Tacos? Tacos? Tacos in a coconut? Yeah. I worked hard on this, guys. Tacos on a coconut, here we go. So we see a trace happening, I think this is the one. Yeah, this is a very simple trace. So it says, somebody did create recipe, we did a call to a endpoint, and then which gave us an error, and then we did a call to that OpenAI instance. So we know now that this has happened. This is much more interesting when we use that collaboration mode that has multiple messages. But if we also add an image, you will eventually see pop up here, oh, we're going to create an image, how lovely, and we're going to get it. That is still running. It takes about 10 seconds to do this, but eventually we'll get that image shown just fine. Tacos, tropical feeling in a coconut. And boom, there we go. I say there's not it's a freestyle taco. It's an open-faced taco. Let's just say that. But traces, very useful. Where did stuff happen? But if we look at the structured logs, this is where we can really dig down on how our application behaves when it comes to LLM communication. So let me look at what is the most important here. We have create recipe invoking. There we go. So we can see here that for some reason, this function is now being invoked. We know it's a kernel function. We know where it's coming from, the SDK name, everything's there. But the most important thing is we can see the arguments. This is a trace value. There is a reason that this is a trace value, because this is way more information than what you need on production. This could have user input, which means it could have all kinds of private data that you don't want to store. So have this enabled locally, have this enabled on your test and staging environments. It will tell you what's going on. Maybe on production, take care. Or filter out the PII. You can do that with an LLM for extra bonus points. But just make sure that you enable this for specific environments. Because here I can see exactly what goes into that prompt, which in my case is 2 select boxes, but could be a chat message from a user on a chatbot for mental health. Do not store that. Thank you very much. So we can see more here. So we can see the actual rendered prompt that I showed in the chat page before. So I can see here what the entire prompt is that went to the model. Again, something you wouldn't enable on production, but something that's very useful while you're testing this app. And then, more importantly, we can see here, there's a trace message, but this is also being posted as a metric, how many prompt tokens this took. So how many tokens went in, because you pay for those, how many tokens go out, because you pay for those as well. Together, this is what you actually get billed for. Depending on the model, you might get billed for both separately. This will help you determine how much is this thing going to cost. Not by one trace is not interesting, but if we go into the metrics, we could start seeing not you, not you, not you, not you, but we can see how long did things take, sure. But here, completion tokens. We can see how many tokens are being used over time. So you can see over a matter of days, like, oh, I had this many users, there's this many tokens. This month, we're going to pay this much on our Azure bill before you get the bill, which again makes the business quite happy, or at least the people who are in charge of the money. So this is how to monitor that application. And doing it locally this way and seeing it here means you are immediately aware of how much is going on for this. You can also see, I believe, if you use multiple prompts or multiple models, you will be able to see here, oh, GPT-4o mini is this fast, takes this many tokens, to make sure that you maybe switch to a cheaper model for cheaper tasks. So that's a lot of the observability bits. Couple of minutes before I let you go. I heard there was beer, just saying. Observability, super cool. Especially if you build it in your demo about LLMOps, because the first time I gave this presentation, it was one day before the presentation. I flew out, and then I noticed it is broken. But because I did all of this stuff, I went into Application Insights for my cloud deployment and saw, oh, when my application is calling OpenAI, apparently there's a 429. 429 meaning server too busy, but for an LLM that means, yo, back off, you don't have any more tokens left. I was using GPT-4o for all of that stuff, and I just ran over the quota. And I asked Microsoft for more, but my presentation was the next day. So in 5 minutes, I fixed it because of all the LLMOps stuff, guys. I added this on the spot just before my presentation, because all I had to do was say, ooh, let's deploy 4o mini, and then change that prompt to, okay, now use mini, and added that model. And I've not since removed the other models because I still have those deployed as well. I can switch. As soon as one model says, oh, back off, we can switch to a different one. I'm actually working on an update to this that will use Poly to do that as a sort of resilient pipeline that just says, oh, no, this is not happening, GPT-4o mini, take charge, or the other way around. So this is actually very helpful. All of these different parts helped me do this demo that first time that I did it, and I'm sure it's going to break again for my next time. So this is how I envision that LLMOps should work. So in closing, a couple of things I want to make sure we talk about. So things that change together should stay together, and that goes for prompt engineering as well, right? So we talked prompt, parameters, and the actual model. You keep them together, and the best tool to do that right now is Prompty. If you don't think so, find me after and we'll fight. But Prompty right now is a really good way to have that in one file, have a nice consolidated Git history, and you can see the updates that have been happening. Really easy to iterate on. This whole presentation is really about using better tools, but most importantly, I think we deserve better tools. All these big hyperscalers are pushing LLMs and saying, look at all this great stuff. The tools are lagging behind. So it's things like this, these kind of combinations that I think we should just have as a default. And you can take this code later. I have a QR code. So things like Prompty and Semantic Kernel, LangChain, and PromptFlow, use them. Don't go to the OpenAI SDK and use that. It's not been very good. You saw that first demo. There's no chance of making something high quality if there's no abstraction. Semantic Kernel has that. And observability is not just for errors. Even though it saved my butt once before, it's also for pricing. It's also for user interaction. You could, for instance, save some traces if somebody triggers a safeguard or the safety filter that Microsoft has. Very useful features. And again, because the first time I did this, it broke. I think LLMOps is here to stay. I'm confused still that I'm talking about it, but for the next few years, we need to spend more time on this to do this kind of work with confidence, to actually be able to deploy things with the same confidence as we have in all of our other tooling. So with that, I hope you will think about this every once in a while when you're building something with GenAI. If you want to take this code, you can, it's there. But because I made this mistake before, if you're going to copy it, please change it so I don't have to watch my code on your presentation before mine, because that was awkward. So, but keep this, steal it, use it for work. It's MIT licensed. Send me a note if you're using it. Makes me really happy. Thank you, everyone, so much. There is the obvious preview QR code. Would love some feedback. But if not, I have no intention of keeping you here longer because it's drinks outside. Thank you very much.